Some of you were asking me about some of the Connect homeworks on the calorimetry. This is from the second set, where a 36.0 gram sample of an unknown metal at 99 degrees is placed in a constant pressure calorimeter containing 90 grams of water at 24 degrees. The final temperature of the system is 28.4 degrees. What is the specific heat of the metal? And in this case, they're telling you that the heat capacity of the calorimeter is 11.4. So that means you're going to need that number. So in general, you're going to use the equation where Q of the metal plus Q of the water plus, let me get, for some reason my thing is different colors. Hold on a second. Plus Q of the calorimeter is always equal to 0. Now, if they don't give you Q of the calorimeter, then you can cross that one out and not worried about it. But if they do give it to you, that means you're going to need it. That means some heat is given into the calorimeter. So in this case, we are going to use the heat of the calorimeter. So what you're going to do is set up this equation 3 times, once for each one. So you're going to have Q of the metal is equal to S M delta T. And I'll use a different color then for the other one. And Q of the water is equal to S M delta T of the water. And then we'll get another color for, let's see, what haven't we used yet? We use like a pink. No, we use pink. We'll use yellow. Q of the calorimeter is equal to, and in this case the calorimeter doesn't have a mass, so this is where just the heat capacity times delta T comes in. So that's the Q of the calorimeter. In all cases, delta T is equal to T final minus T initial, right? And T final is always the same. Think of this as your cup of tea when you add milk to it. The temperature at the end is always the same. You don't have tea with 2 different parts at 2 different temperatures. So T final, it says here that the final temperature of the system is 28.4. So that's always your T final. And you're going to plug that in to all these equations as T final. So in the first case, you have 36 grams times the 70. Let me go back to the pen. I'm actually not going to multiply because I'm leaning on this thing. Sorry. So this is going to be 36 grams. Maybe I should get a new times the. Actually, this is what you're looking for. You're looking for the specific heat of the metal. So this is what you're looking for. You're looking for S. So it's 36 times S times delta T. And in this case, delta T is 99 minus 28.4, but 28.4 is final. So for this case, delta T, I'll write this up here, is 28.4 minus the 99. So that's going to give you a negative number. Okay. Now we're going to go back to the next one. I'll get back to my green pen so you can follow that. And this is the Q for the water, which is equal to S, which is for water, it's 4.184 joules per degree Celsius rather. And you notice they didn't give you this, but the heat capacity of water is a number that you're going to have to know. I mean, normally on a test, we would either give it to you or you'd have to know it, but since you can look these things up, this is a heat capacity of water, something you're going to have to remember. Times the mass of the water, and the mass of the water they said was 90 grams, and again, yours is each going to be, everybody's going to have a different number here. And then the temperature again is going to be the final temperature. Well, this won't write. 28 minus the 24. Oops, I lost my thing. Oops. Okay, minus 24. Let me get the eraser. Hold on. 28 28, 8 minus 24. We'll write the 8. Okay, so you know what that is. And then the final is this, the heat capacity in the yellow here is now heat capacity is 11.4. And you can see that that one doesn't have grams in it because the heat calorimeter doesn't have grams, times the delta T again. And delta T is the 28.4 because the final temperature is always the same, minus the initial temperature. And the initial temperature of the calorimeter is the same as the initial temperature of the water. So that's also minus 24. And then you put all these together. So now you've got the Q of the metal, which is this one here, and you're looking. Let me use another different color pen. Let's see if I find a third color pen. All right, we'll use purple. Okay. So now this Q gets plugged into the metal, and S's are unknown. This Q, we'll go back to the green, gets plugged in here for the water, and then the Q of the calorimeter, we'll use the yellow again, and this number gets pulled in here, and this is your third number. And all three of those numbers have to add up to 0. And it works out pretty nice because if you remember, this number is going to be negative because delta T is negative. So you bring the negative one over to the other side, and you just add them up, and then you solve for S. So I'm not going to do the actual work because everybody's going to have different numbers because these things are algorithmic, but this is how you would do that one. Okay, so now then the next one was something similar. I think it's actually even the same question, but another part. I think this is number 12. Or that was 12, and this is 6. Now the other one is the same way. They gave you 25.95 grams of a sample, and they gave you a temperature. And the second one, they gave you the temperature of another thing. This was methanol and ethanol. So you had Q. Different color pen. This one is Q of the methanol plus Q of the ethanol plus Q of the calorimeter is equal to 0. And again, you can just take each one of these, calculate, let me go back to my colors, calculate Q meth is equal to S M delta T. And remember, T final is the same for everybody. And then this was where I think it was a little tricky. The Q for the ethanol is equal to S M delta T. And they didn't give you the S, so you have to look it up. You can either look it up in your textbook, or I will tell you that it is 2.46. If your thing is ethanol, it's 2.46. Okay, so that's joules per gram C. Right. So that was a little the tricky part. You got confused, but they didn't tell you, and you had to go look it up, or it's in the textbook. And then the last part of this one would be Q of the calorimeter, and that one is equal to, this is just written as heat capacity delta T, and the heat capacity, I think if I have it written here, where did I write it, is 19.3, but again these numbers might change, 19.3 times delta T. And now you have the three terms that you're going to plug into there. This term, one of these terms is going to be negative because it's starting out hot and cooling down, so that negative, the delta T is going to be negative because T final is less than T initial, and that just makes that's how you know which one to bring over to the other side. So you just plug everything in and solve for S. And S in this case, it should be a number around 2. Like I said, these numbers are going to be different, but the numbers are on the order of magnitude of 2 in this case. It's not going to be, a huge number or a teeny number. This other one here, the S, is actually a smaller number. I think this number is about 0.5. I won't write it, but this is a number that should be about between 0.5 and 0.8 or something like that, depending upon what numbers they gave you for different grams in the samples. Okay, so hopefully that explains how to do 2 of these calorimetry problems, and we can do We can do some more Thursday. Oops. We can do some more Thursday. I don't know what happened. How to turn this. When we have